Hello everyone. In 7.4 we will start looking at trigonometric equation, and this is super fun to do. By fun I mean annoying. So let's get started. So we want to solve, of course, trigonometric function, and we also want to solve trigonometric function using a graphing utilities. This is gonna be easy. The first part is gonna be the part that we need to study the most. So to solve trigonometric equations algebraically, we want to, similar to solving any equation, we want to isolate the thing that we are looking for. So in this case, it is a trigonometric function, if we can, right? So if we cannot, then there's nothing we can do. But if you can, isolate the trigonometric function. And then we want to use the unit circle to solve for the variable. So there are a few things that we want to keep in mind. Always look at the solution range, because for trig, they would give you, say, x equals or theta 0 smaller than or equal to theta smaller than or equal to 2 pi. They always going to give you some solution range like that you want to make sure that your solution is within this range. The second thing is keep the period of each trig function in mind. So as a reminder, sine and cosine function, the period is 2 pi. Tangent and cotangent, the period is going to be pi. And also for secant and cosecant, the period is 2 pi. Because secant and cosecant, technically, they are just sine and cosine, right? And also one more thing, that for sine and cosine, you're always going to be able to find two solutions, at least two solutions. And same thing for secant and cotangent. And I'm going to show you what I mean by that in just a few minutes. Besides from the basics trigonometric equation, sometimes they will also give you trigonometric equation in quadratic form. So what do I have? I will have something like a sine to the second square of theta plus b sine theta plus c equal to 0. And you can see that because you have sine to the second and sine, there is no way you're going to isolate this trig sine function. Okay, so if that's the case, if you see something to the second, you want to let that thing equals to x. This is not sine x, this should be sine theta. You want to let that thing equals to x, and when sine equals to x, this would be x to the second x, and then you end up with a quadratic equation. And we can definitely solve by quadratic formula. And then once we get the quadratic formula, keep in mind what you're looking for is theta, not x. So the final step would be solving for theta. And also everything has to be in terms of one trig function. Okay, so it has to be either sine, everything is sine, or everything is cosine. So when we have two or more trig function, you want to keep these useful trigonometric identity in mind. So we have sine to the second plus sine cosine to the second equals 1. Tangent square plus 1 is secant square, and cotangent square plus 1 is cosecant square. Okay, so I should be stopped talking about all the instruction, and let's do some example. So the very first example I have is solving trigonometric equation on the interval 0 smaller than or equal to 2 pi to theta smaller than or equal to 2 pi only. Okay, so this is my solution range, and we want to keep that in mind. The first problem I have is 2 sine theta plus 3 equals 2. I want to isolate sine theta. As always, if we want to solve something, we need to isolate it. So what do? I subtract 3, and then I divide by 2, right? So subtract 3 divided by 2, I'm doing a lot of shortcut here, but I should get negative 1/2. Should I write down? Maybe I can just write down for you. Only on the very first problem. So let's do minus 3 2 sine theta would be negative 1, and then divided by 2 sine theta equals negative 1/2. So this is what we're looking for. We're looking for an angle such that when we take sine of that angle theta, we're going to get negative 1/2. And here comes the unit circle. Okay, so sine is the y-axis, and we have negative 1/2 would be right here, right? So the angle that I have negative 1/2, I will have two of them actually. So the first angle would be this one, and the second angle would be that one. So it should be, this will be negative pi over 6. Remember the special angle, we have pi over 6, pi over 4, and pi over 3. Pi over 3 would be like that kind of big. So nope, that has to be pi over 6. And this will be another pi over 6 right here. So we have pi starting from the initial side, pi, and then pi over 6. So this angle right here would be 5, 6, 7 pi over 6. My bad. What I have is I only take pi plus pi over 6. Okay, and that is going to be your answer. You just simply kind of stare at the unit circle. I will have theta equals negative pi over 6 and 7 pi over 6. So, and I thought I would be done right here, but actually I'm not. The reason is, as I said before, we need to look at the solution range. It only goes from 0 to 2 pi. So if we have a negative angle, it's not good. The good thing is for sine function, the period is actually 2 pi. So if we have a solution that is not within the range, the desired range, you can always add 2 pi, okay, to get more solution. And this one also, you also get to add 2 pi. So let's see what we have. We're gonna have adding 2 pi would be 12 pi over 6. So that would give me 11 pi over 6. That is good. This solution, I'm going to keep it the same because it's within 0 and 2 pi. And then I'm going to try adding 2 pi to see if I have any other solution. And when I add 2 pi, I should get 19 pi over 6. And obviously, this one is around 3 pi, not 2 pi. I only want to go up to 2 pi. So even though this would be, I don't know what happened. Okay. So even though this would be a solution, but it's not within the range, therefore, I am not going to take it. And my solution is theta equals to 11 pi over 6 and 7 pi over 6. Okay, now let's move to the second problem. I have tangent theta plus 1 equals 0. Again, I'm going to isolate the trig function equals negative 1. And from here, I'm going to stare at the unit circle. Okay, so what do I know? Tangent theta is sine theta over cosine theta equals negative 1. That would mean sine theta equals negative sine theta. Okay, so they are the same, just opposite side. Again, what are the special function we have? Pi over 6, pi over 3, pi over 4. Out of these, which one give you same sine and cosine value? Only pi over 4, right? But you want opposite number, opposite value. So it's actually going right here, where sine is positive, cosine is negative, and right there, where sine is positive, negative, and cosine is positive. So this angle would be 3 pi over 4, and that angle would be 7 pi over 4. Okay, and then I'm done. I only have two, because if I were to go around the circle one more time, I would pass 2 pi, and that's not what I want. So theta, basing on the just basing on the problem, I would get just the unit circle, 3 pi over 4 and 7 pi over 4. That is my answer. Okay, now let's move on to the next one. For cosine of theta plus 6 equals negative 2, simplify, isolate secant theta. Secant theta would be negative 2, but I don't know secant theta. I only know sine, cosine, tangent. So I can always bring this back at 1 over cosine theta equals negative 2. Therefore, cosine theta equals negative 1/2. Okay. Again, unit circle. Negative 1/2 cosine theta. It would be right here. Right, so the angle I have should be this one and that's one. Again, we have pi over 6, pi over 4, and pi over 3. Which one is it? This look like a big angle. So for pi over 6, I am trying to find. For pi over 6, it has to be something very small like that. Something very small like that, which is not what we want, right? So this is not pi over 4, so it has to be pi over 3. So the angle I have right here actually is 2 pi over 3 and 4 pi over 3. Okay, and that is done, because if I go one more rotation, I'm gonna go past 2 pi, which is not what I want. So my answer theta would be 2 pi over 3 and 4 pi over 3. So this would be very helpful if you are comfortable with the unit circle that I has been trying to get you comfortable with. I don't give you a table just because I want you to kind of work through it and get used to it. So that's why. Now let's move on. Let me stop talking nonsense now. Okay, next problem. 3 square root of 2 cosine of theta plus 2 equals negative 1. Isolate the trig function. Cosine theta would be negative 3 over 3. So square root of 2 would be negative 1 over square root of 2, or the other way is negative square root of 2 over 2. Okay, so what do we have? Unit circle. Cosine is negative 2 square root of 2, so we know this, the angle associated with this number is pi over 4. But we want a negative, so it has to be somewhere on the left half circle. So it's going to be like that. The angle would be 3 pi over 4, 6, 7, and okay, I'm counting 1 pi over 4, 2 pi over 4, 3, 4, 5 pi over 4. Okay, and that's my answer. So theta is 3 pi over 4 and 5 pi over 4. Okay, next one. For cosine to the second, theta equals 1. Isolate cosine, cosine squared theta equals 1/4. So taking square root, cosine theta would be plus or minus 1 over square root of 4. So that would give you, don't forget, plus or minus 1/2. Okay, so cosine equals plus or minus 1/2 would be, 1/2 would be right here. So the angle I'm looking for is this one, that, and that. And when you look at this, you see that you would want pi over 3. This is not pi over 6. So this would be pi over 3, 1 pi over 3, 2 pi over 3. And when you go here, would be 3 pi over 3, which is pi. And this would be 4 pi over 3, 5 pi over 3, which you don't want, and then 6 pi over 3. Oh, no, 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 no. This is not 5 pi over 3. Sorry, my bad. This is 5 pi over 3. We only have 3 pi over 3 and 6 pi over 3 right there. Okay, so I am getting all of these 4 that I'm looking for. So theta would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, next one. Secant of 3 theta plus 2 equals negative 2. Okay, so that would be 1 over cosine of 3 theta over 2 equals negative 2. So cosine of 3 theta over 2 would be negative 1/2. Okay, so as we've seen a lot of this by now, cosine equals negative 1/2 would give you right here. So the angle we're looking for is 2 pi over 3 and 4 pi over 3. Okay, so remember the angle is this whole phrase, not just theta. So we'll get 3 pi over 2 equals to 2 pi over 3, and also 3 theta over 2 equals 4 pi over 3. Okay, but we need to solve for theta. So from here, solving for theta, I'll get 4 pi over 9. Okay, and then from here solving for theta, I would get 8 pi over 9. So technically you might be done. However, remember the range for solution is going from 0 to 2 pi. And we have this one right here is very small. Of course, we know this one right here is almost equals to pi, approximately pi. So you see that the solution we have up to the final range is kind of far. The biggest solution we have going to 2 pi is kind of far. And because we're looking at cosine, actually secant, the period is 2 pi. So that is when you want to kind of adding 2 pi into each of these and see if you can get some more solution. Okay, so now if we add 2 pi to the first one, we'll get 8 pi over 3. And this would give you 10 pi over 3. Same thing solving for theta. This would be 16 pi over 9, and this will be 20 pi, this is over 3, over 3. Okay, so now let's look at the two new solution. If we have 16 pi over 9, is it still in the range of 0 to 2 pi? Yes, so this is good. How about 20 pi over 3 over 9? 20 pi over 9. This one is not in the range. So I'm not going to take, because 18 pi would be 2. So that is not. Therefore, my solution would be 4 pi over 9, 16 pi over 9, and 8 pi over 9. That's the final solution. Okay, so again, if you see solution from the original, because we have the original angle, so these are the two original angle coming out, and this is way too far from 2 pi, then maybe you want to add 2 pi to each of the angle to get new solution, and perhaps you get some more solution. Okay, so be careful with that. Now let's move to the last problem. I have cosine of 2 theta minus pi over 2 equals to, I don't even know what this equal to. Maybe 1, give me a second right here. Equals -1. Okay, so since cosine is already isolated, I don't have to do anything. Cosine equals -1 would be right here. So that's the angle we're looking for, pi. And that's all I know. I will have 2 theta minus pi over 2 what equals to pi. Solving for theta, 2 theta equals, add pi over 2 to both sides, 3 pi over 2, and theta would be 3 pi over 4. Okay, this is a answer for sure. Yes, this is an answer for sure. But again, see how the solution range is 0 smaller than or equal to theta, smaller than or equal to 2 pi. And 3 pi over 4 is kind of like right here. And you have one whole rotation to work on this problem. So it's kind of way too far from 2 pi. And that is when we may need to add right here plus another 2 pi would give us 3 pi. So solving again, we'll have 2 theta minus pi over 2 now equals to 3 pi would give you 2 theta equals to 7 pi over 2, and then theta is equals to 7 pi over 4. And this one is within the range of 2 pi, from 0 to 2 pi. So that one is a good one. Now, if you want to, you can try another solution plus another 2 pi. That would give you 5 pi. And let's see. Then we'll have 2 theta minus pi over 2 equals 5 pi. 2 theta equals 11 pi over 2. And theta would be 11 pi over 4. This is actually equals to 11 divided by 4, 2.75 pi. So this one is outside of this range. So no, I'm not going to take this. Therefore, my solution, theta would be this one, 3 pi over 4. And this one, 7 pi over 4. Okay, and that is it for solving equation. We have a few more type, but I'm going to see you in the next video with those. Bye.